Good day, students. This is Safia Ademola Johnson, your chemistry tutor and your biology tutor. We want to continue from stoichiometry that we started earlier in the previous video. If you have not watched it, you can watch. So, what we want to look at now is volume, the concept of volume in stoichiometry. The concepts of volume in stoichiometry. Stoichiometry. Now, to start with, we need to talk about what volume is. Volume is the size of the three-dimensional space occupied by a substance. The size of the space occupied by a substance. Now, the SI units of volume, the SI units of volume are decimeter cube, which is equal to dm raised to power 3, centimeter cube, which is cm raised to power 3, liters, liter L, and so on and so forth. Now, the volume of a liquid substance can be measured by any of the following devices. Number one, we have graduated pipette. We have burettes. We have measuring cylinder. We have measuring cylinder. We have volumetric flask. Now, let me show you what I'm talking about here. This is a graduated pipette. This year's NECO practical chemistry, they asked them to list two apparatus that can be used to accurately measure 9.0 something centimeter cube of a liquid. So any of this one can be. This is a pipette. This one, the capacity of this one is 25 mil, which is 25 cm cube. You can see here, 25 centimeter cube. So it has a ring here, a brown ring. So if I take this one and use it to suck a liquid, and the liquid rises up, and by the time the meniscus touches this ring, then what the volume of the liquid I've put inside this material is 25 centimeter cube. That's the volume. Then another thing we use to measure the volume of a substance is the burette. This is a burette. You can see that it is at this place, it is calibrated. This is 0 centimeter cube, and the last number here is 50 centimeter cube. So the capacity of this, the volume of the liquid this one can carry, the maximum volume is what? 50 centimeter cube. That is the burette. Then you have the measuring cylinder. This is the measuring. This one is 10 mil measuring cylinder. It's a small one. You can have bigger ones that can measure up to 1,000. You can see 10 here. 10 mil, 10 cm cube. This is from 0 cm cube to 10. So if I load this one now and the liquid gets to this 10, so the size or the space occupied by the liquid is what, 10 centimeter cube. I may also take it to maybe 6. So that is that, about that. Now, we also have volumetric flask. This is volumetric flask. It also has a ring at this place. So if I pour water or any liquid here and it touches this, the meniscus touches here. Now, then what I have here is what? 1,000 mil, 1,000 cm cube of the liquid inside it. So that is a volume. Now, take note of one thing also about volume. Another thing you need to know about volume is that now 1 dm cube of a substance now occupies 1,000 cm cube of volume. So that will tell you that 1 dm cube is equal to 1,000 centimeter cube. Take note of that. Then another important thing is now 1 mole of any gas. It doesn't matter whether the gas is hydrogen, whether the gas is oxygen, whether the gas is nitrogen. 1 mole of any gas occupies 22.4 dm cube or 2,400 cm cube. So now at STP, so this 22.4 dm cube or 2,400 cm cube now is the same as molar gas volume at STP, also called it molar gas volume. So that is the space 1 mole of any gas will occupy. Take note of that. Now, then the mathematical formula, the stoichiometric formula for the determination of volume are: number 1, we have volume, we have number of mole equal to volume over molar volume. Then number 2, we have CV over 1,000 equal to volume over molar volume. Then number 3, you can see half, okay. Okay. Sorry, this should be mass over molar mass. Mass over molar mass. So, C over 1,000. Then you can see half mass over molar mass is equal to CV when volume V has the units, the SI units of dm cube. That's when you don't need to divide it by 1,000. So, and take note, C means concentration in mole per dm cube or molar. Capital letter M, when you see capital letter M after a number, it means concentration, it means C, concentration in mole per dm cube or molar. Take note of that. Then we also have mass over molar mass equal to volume over molar volume. Mass over molar mass equals to volume over molar volume. Now, how do we use all these formula we are talking about? How do we use them? Yes. Let's look at how we can use them. We look at example 1. Example 1. In example 1 now, we want to see how we can have this number of mole. You are given the number of mole. You are given molar volume. You are asked to find volume. Let's check. He says, find the volume of 0.3 molar of H2SO4. Now, okay, of HCl, of hydrogen chloride, HCl. Then they will give you H equals to 1. You don't need that. They give you molar gas volume equals to 22.4 dm3. So that's a question. That's a question. How do we solve this? Find the volume of 0.3 molar, which is empty as mole per dm3 hydrogen chloride, HCl. Now what do you do? What do you do to solve this problem? To solve this, your number of mole has been given to be 0.3. Okay. Oh, let this one be mole. So it has been given to be what? 0.3 mole. Yes. Then your volume. That's what they say you should find. It's unknown. The molar volume has been given to you to be what? To be 22.4 dm3. That's what we have here. Then use your formula now. Number of mole equals to volume that you are looking for over molar volume. So number of mole is already 0.3. What is the volume you are looking for? Molar volume is 22.4. We cross multiply our volume. We now be 0.3 times 22.4 dm3. So our answer now gives us we have 0.3 times 22.4. Our answer is 3.72 dm3. Why are we using dm3? Why are we not using cm3? Because the molar volume given to us is in dm3, so the volume we are going to get must also be what? dm3. Let's look at example 2. In example 2, now I want to look for how we can use this formula. That means we must get a number that has capital letter M or more at its front to represent C. Get a number that has CN cube or DN cube. Okay, CN cube at the back to represent V. So then we must get a number that has gram at the back to represent mass. Then certain numbers, some numbers will be given to represent the molar masses that we can use to find the molar mass. Let's look at the question. You can be asked to find, determine the volume of 0.03 mole per dn cube of this this mole per dn cube now is representing our C. So we are looking for this one. So we must also have a parameter that has gram at the back. So determine the volume of 0.03 mole per dn cube of 35 gram of now H2SO4. So you have this. Determine the volume of 0.03 mole per dn. So then, to find the molar mass of H2SO4, which is here, your H will be 1, your S is 32, your O is 16. So if that is the case, then our formula to use is what? Our formula to use now is what? Is mass over molar mass equals to CV over 1000. What is our mass? Our mass is the number that has gram at its back. 5 gram. That's 5 gram. Then what's our molar mass? Molar mass of H2SO4 will be equal to, hydrogen is given to be 1, but inside H2SO4 we have 2 of them. So we have 1 to represent this H, then times this 2 that is there, plus sulfur is 32. And we have only 1 sulfur, we put it there. Plus oxygen is what? 16. And we have 4 of them there. So we have 1 times 2 is what? Is 2. Plus 32. Plus 60 times 4, that is 64. Add up these 3 numbers, we have 98. The unit of molar mass is gram per mole. Or you don't put unit, no problem. Can leave it like that. So now, then what else do we need to look for? Our V is unknown, that's what we are looking for. So you put in your parameter, instead of mass, put what? 5 gram, 5, over, instead of molar mass, put 98, equals to, instead of C, put a number that has more per dn cube. Do we have? That's 0.03. So we now have 0.03 times the volume we are looking for, V, over 1000. So what do we have? Can we write this as 5 over 98 equals to 0.03 V over 1000. So it's to cross multiply. We have 98 here times 0.03 V. Then this equality sign, we write it back. 5 times 1000, which is 5000. So by our calculator, we have 98 times 0.03. And the answer is what? Answer is 2.94 V. Is equal to 5 times this 5000. So we divide both sides by this number, our V will now be 5000 divided by 2.94. Our V will now be equal to, so we have 5000 divided by 2.94. Our final answer is 1.70. What unit are we going to put? The unit we are going to put is CN cube. Why? Because in the formula there is over 1000. And if in the formula there is over 1000, then the SI unit would have been what? DN cube. Now let's go on. Yes, I want us to manage this space so that we will not rub off the formula. We can be using them. We have used number 1, we have used number 2. So I can take this one away. Then example 3. In example 3 now, I want to learn how to use this one. Now, you are asked to find the volume of 3.8 gram of NaCl whose concentration is 0.5 capital letter N, which means molar. Now, in decimeter cube, they want it in decimeter cube. If they want volume is decimeter cube, then from here you also have what? Na equals to 23, Cl equals to 35.5. Then, so from here, the formula to use is mass over molar mass is equal to Cv, not over 1000, because the volume is required in decimeter cube. They might not say in decimeter cube, but what of if the question is an OBJ question and all the SI units of all the options there are in dm cube? Then it is time to use this particular formula. Now, so what do? We write out our parameters. Our mass is any number that carries gram at its back. Mass is any number that carries gram, which is 3.8 gram. Our molar mass of NaCl will be calculated with all this. Na is 23, Cl is 35.5. So we have 58.5 gram per mole. Now, we come back to the formula. Then our C is any number that carries either capital letter N or mole per dm cube. That's 0.5 molar. So that is that. Then our volume is unknown. That's what they asked us to find. Then come back, our mass, we put 3.8 to represent it. Over molar mass is now what? 58.5 equals to, then what do we have? C, that's 0.5 times what's our volume? That's what we're looking for. Now everything over 1. So this same thing as 3.8 over 58.5 is equal to 0.5 V over 1. So we cross multiply. We have 58.5, which is this one, times 0.5 V, then equals to 3.8 times 1, which is equal to 3.8. Then, what do we have there? We have 58.5 times 58.5 times 0.5. So, and our answer is going to be 29.25 V. So what do we now do? We divide those by our V. And we come here, to now say, okay, our V is equal to 3.8 over 29.25. So if that is the answer, if that is the case, our V can now be equal to what? So let's press that. We have 3.8 divided by 29.25, and our answer is 0.13 dm cubed. So that is what we have there. Now, then let's learn how we can use this formula now, the last formula. Mass over molar mass equals to volume over molar volume. Let's look at another example there. Now, it means to be able to use this one, we must have a number that has gram to represent mass. You must have something like this to find molar mass. Then you are asked to find volume, and you must give it molar gas volume in the question. Let's look at one. Now, find, that's example what now? Example 4. You are asked to find the volume of mass 3.9 gram washing soda. Okay. Of what else do we need to know? We need to, okay, the mass, then the molar mass will be given, then okay, of washing soda. And the washing soda is Na2CO3. Find the volume of 3.9 gram of washing soda solution. Now, what do we have? We'll be giving Na equals to 23 to represent this, C equals to 12 to represent carbon, O equals to 16 to represent oxygen. Then we now say molar gas volume at STP is now given to be 22.4 gm3. Now, you can take away this space. Then from there, you can bring out our parameters. Mass is what? 3.9 gram. Then molar mass of Na2CO3 will be calculated for, instead of Na, put what? 23. But in the formula you have 10, you have 2, so you multiply by 2. Instead of carbon, put what? Put 12. But you have only one carbon there. Then plus what? Oxygen. Instead of oxygen, put what? 16, but you have how many oxygen here? 3. So this one is going to give us what? 46 plus 12 plus, what do we have? 16 times 3. 16 times 3. That gives us 48. So if you are able to add everything together, we get 106. 48. So add them together. So the molar mass is what? Is 106 gram per mole. Don't forget, it's not supposed to put SI unit for molar mass. So you have gotten that one. Then what else do you need to know? You have known molar mass. Then what about your C? Any number carrying capital letter M or mole per dm cube? So okay, what's the formula we are using? Okay, we don't need that. So we don't need that one because our formula is mass over molar mass equals to volume over molar volume. So the molar volume has already been given to you. So then put in your formula is what? Mass over molar mass equals to volume over molar volume. Now, any number carrying gram at the back, that's 3.9 over the molar mass has been got to be what? 106. Is equals to volume that you are looking for. You don't know it. Write it like that. The molar volume has been given to be 22.4 dmq. And the work is done. You can cross multiply. 106 times volume becomes 106 volume is equal to 3.9 times 22.4. So now, I'll take this place away. Now, yes, I can have 106 volume is equal to, what is our answer there? Our answer there is, we have 3.9 times 22.4. Our answer is 87.36. So divide both sides by 106. So we have volume now. Volume will now be 87.36 divided by 106. Our volume now will now be divided by 106. Answer is 0.8. Answer is 0.882. What is the unit we are using? dmq. Why are we using dmq? Because the molar gas volume given to us is in dmq. So that is that. So we are going to draw the curtains here. These are the various, just all you need to know is the various formula in which volume is present, which I have given to you, and just make the volume the subject of the formula, then the problem is solved. So see you in the next video, where we are going to stoichiometry of number of mole. So watch out for the next video where we are going to talk about that. So I remain my humble self, Afia Ademola Johnson. Don't forget to share this video, like it, and like it, share it. So please don't forget, share the video, like it, and subscribe. So click the subscription button to subscribe, so that every video I post, they will get